there is not supported something like this.
Okay. See, Payal, you should have told that earlier, because what happens is that now it's the end of the course. Had you told this earlier, then we would have done, something about it. So I don't know what. I don't know
Sir,
what. Bolo.
sir, this phase is transfer any courses for any courses like solid state physics or experimental physics one,
Uh, I
because I till now I not submit or not paid this fees.
okay, 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 okay. No, what was your question? Can you ask your question once more?
Sir, I don't pay uh, my fees in for a solid state physics course and experimental physics course.
Mm-hmm.
So,
Mm-hmm.
if possible, this course fees uh, numerical methods and simulation for scientists and engineers. This course fees 1,000. Can I transfer this fees from
I
this
don't know.
to
I
solid state physics?
I I don't know. I don't know. I don't know. See, those are I'm the instructor for this course, not the administrator. Okay.
Okay.
Those are administrative issues. I do not know anything. Vijay Lakshmi, do you want to ask something?
Hello, good afternoon.
Yeah. Good afternoon. Yes, Sumit Banerjee, you can pose your question.
Okay, I have a few questions. Can I ask them one by one, or should I post them in the chat?
No, no, you can ask me.
Okay, okay. Give me a second. I'll open up the questions. Okay, so first question, Professor, is coming from stratified sampling.
Mm-hmm.
Okay, so in the stratified sampling, there was a term which is the volume of Rj, and that was used to calculate the expectation values of the term that we're interested in. Now I'm trying to understand where exactly is this volume Rj coming from, And let's say if I have a two-dimensional space, so in what do I say? In that configuration, what does this volume Rj imply?
I do not know exactly what you are talking about. What is volume RJ? What is the connection? If you are,
Okay,
can
okay.
you show something on the screen or something? Can you share something?
I have my notes. The problem is I have them on my notebook. I
Okay.
can refer to the lecture if you like. I can go back to the lecture where this term was introduced to us.
Okay. 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 Can
Give
you? Okay. Uh, okay. Suppose we. Okay. You can. So you said what is this VRJ?
Yes. So this is coming from the stratified sampling part of the lecture on importance sampling and the pitfalls of importance sampling. I think it was there in the 7th week,
Okay.
and it is coming from the stratified sampling, which is one of the variance reducing techniques.
Okay.
And in the
Okay.
derivation, you gave us this thing: the expectation value of anything, E of fx is written as the integral over fx into px dx. That is
Okay.
okay,
That's
that I
right.
understand. And then
Mm-hmm.
in the next step, you say the MC estimate of the expectation becomes I is equal to summation j is equal to 1 to k,
Mm-hmm.
volume Rj divided by Nj. Another in summation I is from 1 to Nj f of xi. So this was the expression that was given.
Eh,
And
okay. Okay. Sumit, what will be best is that if you
Mhm.
could refer to the lecture and write an email to me, I'll be able to give you a more detailed reply, because
Okay,
this looks like I need to see and answer instead of, because I'm trying to recall and I'm not getting a complete recollection of that. Okay.
okay,
So,
Professor. I will.
but yeah, you please write and I'll write back.
Okay, sure, sure,
Yeah.
sure.
Okay.
I will do this.
Okay. And what is the next question?
Okay, this is a very basic statistics question.
Mm-hmm.
And in the MC simulation technique, you said variables which are correlated and dependent. So there are two terms. One is correlation. One is, I think, variable dependent or independent of each other. And
Mm-hmm.
you said there is a okay. My question is, you said that two variables can have zero correlation and yet be dependent on each other. You gave an
Mm-hmm.
example there. I agree that you gave an example, but somehow I still cannot understand if there are two variables which are not correlated, how can they be dependent? So if you can just give me an idea of what exactly is this and how should I interpret this part?
Again, it of course requires me to see the context, but I mean, in the sense that they don't have to be correlated, which means either at different times the values are independent of each other, but there is a functional relationship between the two.
Okay.
Okay. Now that functional relationship says that at two different times that they could be, suppose a variable depends on x and t.
Hmm.
So temporally they can be uncorrelated. That is, they may not have any relationship, but they may have, they may not have relationship between a time t1 and a t2, whereas they may be actually dependent on each other by the x.
Okay.
So a particular quantity or a particular observable can depend upon a number of variables, and it can be correlated in some sense, but they can be dependent on another sense. That is, they are dependent on through a relationship in terms of the other variable.
Okay. Okay.
So that way they can, but again, please write to me and sort of mention exactly which context you're talking about. So that will help me to answer you better.
So I posted these questions on the discussion forum,
Oh,
and
you did?
I think it will have a link to the timestamp on which I'm asking this question.
Okay, fine, fine. I will go back and I'll do it quickly, as quick as I can. I'll try by the weekend or something, because the TAs actually told me that there are some questions. One question was, I'm not too sure whether it was from you, but it was. Yeah, it was some questions which I needed to, oh yeah, it was about how in a bisection one can actually bisection method one can actually have an idea about all those the lower limit and the upper limit, such that you can have the guesses, so something like that. But I'll look at this, I'll look at your questions definitely.
Okay, sure, Professor. I have a few more questions, but I think I'll anyways ask you these questions. So let me know if you need a reference to the lectures. I can then maybe write you back on this. The next question is coming from the finite difference method. Okay, so it was actually, I got confused in this because there were two variables, temperature and time, on which the function u, there was a parameter u that was taken in the lecture, on which u dependent on two things, space and temperature, as per the lectures. And then my confusion was, in the grid that you drew in the lecture, the grid was actually time dependent. So I just got confused whether did I miss whether the t is a temperature dependence or whether it was a time dependence. So that is where I did not follow that method at all. I need to go back, but that is, if you can just give me an idea, that will help me understand the method in a better way.
Sure. I'll have a look at that. I'll definitely have a look at that. I believe you have posted the question as well.
I have the questions. I'll do one thing. I'll collate all of them because they might be scattered, and I will send a consolidated email to you with the lecture and the timestamp. Will that help?
Absolutely.
Okay, Professor. I will send you the. I have just one more question, which is again a very lecture specific question. So I'll stop the questions now, which are very lecture specific. So yeah, I will send you then email maybe by today evening or maximum by tomorrow afternoon. I'll collate everything and send you an email.
Perfect. Perfect. And may I ask, what do you do? I mean, like.
Professor, I'm a student, master student of astrophysics.
Okay. Which place?
I'm logging in from UK, Professor.
Oh, okay. Thank you so much. I sorry that things are not fresh in my mind, and neither do I have the lectures. But I'll definitely get you answered for sure.
Sure, Professor. I look forward to the answers.
Absolutely.
Professor, before stopping this, since the course is now come to an end, and I am someone who is interested in computational astrophysics, mostly simulating the cosmological equations that we have. So, if I may ask, what will be the next logical step to take forward after having completed this course?
See, I'm not from astrophysics. I'm a condensed matter physicist, but astrophysics requires you. Suppose you talk about Raychaudhuri equations, or Penrose equations, and so on. So ultimately, these are some differential equations that you have to solve. And these differential equations, the solution of the differential equations are going to be iterative methods. And these iterative methods are already, being talked about in the course. So it will be nice that if you take an equation which is, you are reading right now, and try simulating it numerically, and, prepare a trajectory of things, a density as a function of time or whatever, or say give you a problem from your field, is that if you can look at Chandrasekhar limit, is basically the white dwarf stars, and the white dwarfs are, there's the stars that are almost dead, and these are sort of things which are completely used up, and they are left with ionized helium gases. And there you can, the basis is statistical mechanics, and then you get certain equations to solve in order to get the Chandrasekhar limit, which gives you a radius of these white dwarf stars, a limit on the radius of these white dwarf stars. So similar things, if you are going to do astrophysics, or if you're already doing astrophysics, it'll be good to solve certain known equations by using the numerical methods to get your hands, or build up your confidence on that they are really giving you results which have been obtained by others. Sometimes all these, there are packages available which eventually use the same numerical method as has been taught. The world is moving more and more towards automated softwares which would do the calculations for you. But they remain as black boxes most of the time, unless you, you see it yourself that how things are working. So it will be a good opportunity for you to test them using the methods that we have discussed in the course. And also, when there are several softwares available which would do a solution of a differential equation, second order, third order, whatever. But the solutions would be coming from a black box to you. So if you could convince yourself that this is indeed the kind of solutions that you get, that'll be nice.
So I tried solving the Friedman equation for cosmological lambda CDM model of the universe. And when I solved them using SciPy is a package in Python, and I developed my own small routine using the Runs-Kutta fourth order method that was there in the lectures. The thing is, somehow my algorithm does not converge at all. I mean, it keeps on going on. Maybe I don't know. That's the reason, because I followed everything that I could from the lectures.
Okay.
I went through it several times. I
Okay.
tried doing this, or somehow it does not give me any. It does not converge at all. It keeps on going forever.
Okay.
So
Can you increase the tolerance a little bit? That is, suppose you have your convergence is set as 0.0001. If you can set it to be 0.001 or 0.01 or 0.05, would it help? That is, sometimes what happens is that your numerical, because these are solving differential equations iteratively. So if you are somehow going into a regime where this iteration does not get you back within the tolerance, or within the sort of set value, that is the tolerance value that you have set, and then it might go into trouble. But it will be nice to actually see that whether if you increase the tolerance, whether they really converge.
okay. Thank you, Professor. I'll try that one out. No problem.
Sure. Thank you so much.
Thank you.
NPTEL IITG.
Sir.
Yeah, so if there are no questions, then could we stop in 4 minutes, which is 3:30?
Okay, sir.
Okay. Is this Rekha or?
Yes, sir.
Oh, Rekha, hi. I'm not in station, so I've joined from outside.
Okay, sir. No problem.
Okay, okay. Payal, if you have no other question, you can also leave. If you have questions, you can ask.
Okay, sir. Thank you, sir.
Thank you.